is lesson 4.2 for Algebra 1. This is writing equations in point-slope form. First of all, let's go ahead and discuss what point-slope form is, which is y minus y sub 1 equal to m, our slope, times the quantity x minus x sub 1. So all we need in order to achieve point-slope form is literally, it's in the name, it's a point and a slope. Let me give you an equation that's in point-slope form. And we're going to actually dissect this thing and see what we're actually working with. Now, we're actually going to be working with a little bit the opposite of what we're anticipating. Notice here that we're subtracting both the x and the y. And also, while we see a coordinate, it's going to be x comma y, right? It's in alphabetical order. We see this in kind of, the y appearing on the left first. It's going to be opposite of what we think, okay? So here, the coordinate that we're working with, the starting point, it's going to be based off of these two things. So the x in this case is actually -2, right? Because if we were to take minus x sub 1, minus would be plus. Our y is going to be 4, okay? And of course, our slope in this case is equal to 3. So -2 comma 4 is our starting point. And then we're going to have the slope of 3 being that while we put down our coordinate -2 comma 4, we'll go up 3 and over 1, and that's how we're going to create our line. Versus slope intercept, where we start at the y-intercept and then move from our, with our slope. We're going to use this starting point instead, right? It's going to be just a little bit different. So let's actually do one of these problems in slope-intercept form, or point-slope form, excuse me. We're going to write an equation in point-slope form of the line that passes through the point 1 comma 6 and has a slope of -1/2. All right, so this guy's gonna be pretty straightforward, okay? Going back to our initial thing, right? So y is gonna be minus, here's our y up here. It's gonna be y minus 6. That's going to be equal to, right? Instead of m, here's our slope of -1/2. And then in our parentheses, the quantity, it's going to be x minus, and then here our x value is 1. It's pretty straightforward. So there you go. That is your point-slope equation. All right, next. We actually have two answers that we can provide here. But we're actually use point-slope form to do the following. We're going to write the equation of the line in slope-intercept form, including the points -2 comma -6 and 4 comma 6. Okay, so think about this. And no matter what, if it's slope-intercept or point-slope, both things are going to necessitate slope. So we know how to calculate slope. It's m. Of course, it's y over x, okay? And let's go ahead and label these guys. This is going to be our x sub 1, our y sub 1. This is our x sub 2. This is our y sub 2. So y minus y. In other words, we have -6 minus 6. Okay, y sub 1 minus y sub 2 over x sub 1. -2 minus 4, right? Which gives us a -12 over -6. And we know that's going to reduce to just being +2. So there's our slope. Okay. We can choose either point. You choose either coordinate, and we're actually going to be able to get this guy done. So let's go ahead and it's going to yield the same thing. I just want to show you guys this. We're going to do this problem twice. You don't have to. You can only do it one of the ways, but this is just out of example because one of these ways is going to achieve what we need. So here we go. -2 comma -6. That's our point, right? So we're going to say y minus 6. So minus 6, which is plus 6, right, is going to be equal to m, which is +2 times the quantity x minus, which is +2. Okay, so let's go ahead and put this guy into slope-intercept form. It's going to be quick, because if we have a slope, right, which we calculated, we can just take one of those points and it's going to actually get us the answer. And of course, we can do this problem a different way, right? We can solve the y-intercept, which is what we did in the previous lesson. But this is just showing an alternate method here. Oops, sorry, we actually have to distribute first. Once we do that, y plus 6 is equal to 2x. Plus 4, right? 2 times x, 2 times 2. Then we're going to subtract 6 from both sides. and y is going to be equal to 2x, and then plus 4 minus 6 is going to be minus 2. So that's our answer. Gentlemen, we're going to get the same exact thing if we do this another way, right? If we use the other coordinate rather than -2, -6, let's use 4, 6, right? So it's going to be y minus y, right, which is 6, equal to y sub 1, which is 6. And then we're going to say m, which is our 2, and then it's going to be x minus 4. And watch what happens. We're going to get the same exact thing. Let's go ahead and distribute that. So y minus 6 is equal to 2 times x is 2x. 2 times -4 is -8. And add 6 to both sides. And look at that. Y is equal to 2x minus 2. Same exact thing. You don't have to do it both ways. Just choose one. Just demonstrating it's the same. Doesn't matter. It's the same line, right? Which makes sense that if it's the same, the line includes both points, the same equation is going to apply to both. All right, so let's look at some different directions. We're going to write a linear function, f, with the values. F of 8 is -1, and the f of 6 is equal to 0. All right, gentlemen, what we have here is we effectively have two coordinates. The f of 8 equaling -1 is effectively showing us the coordinate 8, -1. And the f of 6 being 0 is effectively our coordinate 6, 0, right? So let's go ahead and just do, slope intercept here, okay? So again, x sub 1, y sub 1, x sub 2, y sub 2. To get slope intercept, let's use the point slope form. No matter what, we have to, of course, calculate slope. So we have m, right? Y minus y, so y sub 1 minus y sub 2, -1 minus 0. Over x sub 1, 8, minus x sub 2, which is 6. So in other words, I have -1 over 2, and there we go. There's my slope, all right? So choose one of these points. Let's choose this guy over here, 8, -1. We have y minus 1, which is plus 1. We have our slope, -1/2, times our quantity, x, minus, and then our x value is going to be 8. Again, we wanted the linear function, so it has to be in slope-intercept form. So this should be quick for us. We're pretty good at this now. Right? So we have y plus 1 is equal to -1/2 times x is -1/2 x. -1/2 times -8 is +4. All right? And our last step to get y by itself, so we're in slope-intercept form, we're just going to subtract the 1 from each side. So y is equal to -1/2 x plus 4 minus 1 is equal to +3. And that's our answer. Okay. It's funny. Little problem here. It's going to discuss some kind of antiquated technology, which is, of course, the taxi, something we don't see very often in the year 2020. To ride a taxi, you pay a starting fee and a mileage fee. The table shows the total cost of a taxi ride for different distances. And the situation be modeled by a linear equation. Explain. And if possible, write a linear model that represents cost as a function of the number of miles. All right. So here is our little table that you're going to draw. We have the distance, which is in miles, okay? And some distances we have. We have 4, we have 8, we have 10, and we have 12. And then we also have our cost, which is in dollars. And our costs are 13, 23, 28, 33. First of all, is this modeled by a linear equation? I think the thing that we have to just make a distinction of here is going to be, so here's our D, this is our input, which is our independent variable, our cost, which is going to be C, right? Is going to be our dependent variable, depending on whatever our distance traveled to get our cost. So let's take a look here. What's our common difference? Well, we have a common difference of 4, right? This is our common difference of 2, common difference of 2. So it's right now not sure if this guy looks linear. Again, we have here our common difference is 10, between 13 and 23, common difference between 23 and 28. So it's 5 and then 5. Now, here, demonstrably, right here, this has a constant increase, right? Therefore, it is linear, okay? And now you're looking at this and saying, wait, hold on. It's not always just plus 2, plus 2. Well, this guy here is plus 4, right? Now, if we only, when he was plus 4, it was also plus 10. So it was increasing by a factor of 2, right? Between those two measured distances and costs. So it is a linear relationship. So let's actually just go ahead and take 2 of these points. Let's just take these middle 2, right? Okay? And we're going to go ahead and get our slope. The slope will be the same even if we had taken the first 2 points. Okay? So our slope here, we're going to say 28 minus 23 over 10 minus 8, which is going to be a slope of 5 over 2. Okay? And pretty straightforward here. Let's just take that first coordinate, okay? And we have our cost minus whatever that was right there, right? This first point. So it's going to be 23, okay? Times our slope, 5 over 2, and then our distance is going to be minus, the 8, the same one that's going to correspond. From there, we can make our function, right? We're going to take this guy, we're going to distribute, okay? So c minus 23 is going to be equal to 5 halves times d, and 5 halves times negative 8, right? Right? So 5 times 4, that's going to be a minus 20, okay? And then, of course, last step is we're going to add 23 to both sides so that we have this as a function with cost being, being dependent on the distance as the input. So 5 halves d, and then 20 plus 23. Negative 20 plus 23 is positive 3. So there we go. There is our function. Your lesson is posted onto Canvas. Good luck. If you have any questions, feel free to contact me.